Today's Calculus 3 video is going to go over multivariable implicit differentiation, and it's one of the more simpler topics with very little to learn. So if we're asked to find the del of z over the del of x, all we do is just take the partial derivative of x over the partial derivative of z. You just divide the two and you multiply it by -1. Same goes with respect to y, where if we find the del of z over the del of y, all we do is take the partial derivative of y and divide it by the partial derivative of z. And then we multiply by -1, hence the negative. Now if you're having trouble remembering the formulas to use, all you do is just think of it as cross multiplying. And what I mean is notice over here, the del of z ends up having the z on the denominator. So it once was on the numerator over here and it becomes the denominator over here. The same goes with the del of x, where it becomes the numerator from the denominator. And same goes with the del of z over the del of y, where the del of z from the numerator transfers over to the denominator over here. And over here with the del of y, it's in the denominator, so it becomes a numerator variable. And don't forget to multiply by -1 on both of them. So let's get into an example. So our first problem asks, find the del of z over the del of x for x cubed plus y cubed plus z cubed plus 6xyz equals 1. Now the first thing to do is to set this to 0, which we can do by just writing out the equation and subtracting the right side by itself and subtracting the left side by the right side, which is just -1 equals 0. Now the next step is we need to see what we're looking for. Since we're asked del of z over the del of x, remember our top variable z will go on the bottom with an f in front, and our bottom variable, which is x, will go on the numerator, which just gets the partial derivative of x. And note that all of this is negative. Now to find this, we just simply find the partial derivative of x, which in this case is just the derivative of all of the circled ones, since they all contain x. So that's going to be 3x squared plus 6yz. Now for the denominator, we just find the partial derivative of z, which is just the derivative of the 1 squared here, which gives us 3z squared plus 6xy. Now that we have our missing pieces, we could plug into our box, which overall just gives us -3x squared plus 6yz over our f of z, which is just 3z squared plus 6xy. And that is our final answer. Very simple. Okay, maybe this isn't our final answer because we can simplify this even farther to become -x squared plus 2yz over z squared plus 2xy. Now if you're wondering how I simplified this, I noticed that you could take out a 3 out of each of them, and once you take out that 3, you could just cancel it out and you are left with these coefficients over here.